and this session will be opened by Yuri Raizman from VisionMap Israel. He is a scientific director or chief scientist in that company. He will speak about how to use A3 Edge camera. It looks like everything is okay. Different colleagues, it gives me pleasure to see all of you here, first of all, because our company for VisionMap and for me it's the 8th Rockers conference already, and each time I attend, I come back with huge pleasure and experience, and I enjoy talking to all of you on professional subjects, and not only professional subjects. According to the agenda for today, I will speak about worldwide experience with A3 Edge camera. Actually, yeah, that's the most recent camera. Originally was A3, now it's A3 Edge. But at the very last moment, I decided to present to you a lecture which I read just a couple of weeks in Great Britain. And it is dedicated to oblique imaging and dense digital elevation models and 3D modeling of urban areas. There was such a workshop within the framework of the European Commission for 2 days. It was very interesting. All these presentations will be posted on internet, and I strongly recommend you reading them. Indeed, they are the most advanced, represent the most advanced knowledge on photogrammetry in Europe. Not only in Europe, because Europe is a trendsetter. Let's be honest. And as far as our camera is concerned, I will say a few words about this. This camera is used quite broadly. We have a good sizable market in Australia, in China, Russia, Ukraine, Europe to a less extent, South America, and the camera is broadly used for all sorts of projects. For instance, I can tell you about oblique imaging projects in the Netherlands and Belgium. Oblique imaging done by our camera twice a year for the whole country. Whole country is covered by oblique imaging. It is done for private use. It is a non-governmental customer. Private company Cyclomedia, which uses the oblique imaging for to present this for presentation of this information to municipalities and other users. There are humongous projects in China. One company used 2 of our cameras, and they covered 250,000 square kilometers. That's quite vast area, I can tell you. Now we have 4 or 5 cameras flying there. In Russia, there are quite sizable projects in Moscow Oblast or region. Russian Forestry Department, last year they covered 35,000 square kilometers. Everything was done with our camera, and the processing was done by our software. So this is like a preamble, if you will, for some practical things, but I would like to return now to the subject of oblique imaging and planning and digital terrain models. It is interesting to note that at the very beginning of our discussion there was a question. Why do we need it in the first place? Why do we need oblique imaging? Why do we need 3D digital terrain models? And who are our potential customers? Well, it is quite clear. That would be our aerial imagery companies who we sell our equipment to, and rockers also, but our customers also make their products for somebody else. Who are the ultimate beneficiaries here? Who are the consumers of this cartography or photogrammetric information and images? Well, it turned out that there are quite a number of organizations, agencies and ministries who are interested in this. And in fact, here I try to show some of the things related to emergency management, monitoring of large industrial facilities, urban planning, historical legacy mapping. Sometimes our legacy is crumbling away irrevocably, unfortunately sometimes. Another broad area of application is real estate. I don't know how to say it in English. Yes, now I remember. Real estate. So, real estate valuation, real estate sales. It is quite a popular trend now. And Pictometer, the famous company who started working on oblique imaging 10 years ago, but it was not a photogrammetric company. That is why we never took them seriously. But they started using oblique imaging for real estate valuation and real estate sales. It was their original idea. Later on, they started to develop some products for municipalities and so on and so forth, and many other things, like for taxation purposes. In many towns and cities, there is a rule that you cannot hang out a poster larger than you paid for, or you always pay for the actual area that you cover with your advertisement. And to check it, every municipality can send an inspector. They have special inspectors who double check it, measure it. There are all sorts of land-based programs that would help us calculate the actual area on the billboard, for instance. And the oblique imagery can help us with high accuracy and quite reliably to double check it. I mean, taxation by municipality, for instance, and their tax agency would be potentially quite a good customer for us. 3D modeling for cities is also used quite broadly, and now it has become a routine application. One of the examples of it would be a French company, EMEA, more advanced in this area. It was bought out 2 years ago by the company Bentley, and now it is sold along with the MicroStation, packaged with Bentley. And Bentley prepared a full interface for this suite, and you can introduce changes into this 3D model. You can edit it, introduce your engineering projects, put your new CAD-based objects, see how they play out there, and check all sorts of impacts of other objects to new ones, the shades, all sorts of things. And there are quite a number of such similar programs on the market. China offers a number of interesting solutions here. A3 ArcGIS, most recent version, also supports this models along with editing suites and integration of these objects. And well-known company Meridian from Moscow double-checked all those technologies, and as a result, they developed a very good model of St. Petersburg, one of the few models of a large city, prepared with high accuracy, based on our A3 camera and ArcGIS to integrate the whole bulk of information. In other words, we have many potential areas of application for such relatively new functions of aerial photography and photogrammetry in general. What can we offer? First of all, we have R3 Edge camera, which can work in both color and infrared mode, and a new camera on the market. Well, it was on the market for quite some time, but this year they only allowed to use it for civil market this year. So that's what makes it new. This is a camera which works in a medium thermal range for thermal photography. It is based on the same principle, has a very high resolution, ground resolution, high thermal sensitivity, and we started to promote it in Europe now. Lightspeed software, as you know, is an automatic processing system which includes the main basic photogrammetric processes like triangulation, digital terrain model, including 3 different models, 3 different approaches, and orthophoto. One of the models for the digital terrain model creates true orthophoto or true orthophoto based on DSA. So basically you get a painted or colored cloud of points, and I will show it to you, this DSM, later on. What this product looks like. Oblique Vision program. It could also be part of our supply. It is an Israeli-based program which helps users work with oblique images. And oblique images and orthophoto and GIS layers, all of them can be integrated into a single project. And there could be oblique images for different projects. And Acute3D that I mentioned earlier. It's a software for 3D model building. Here you can see the principal specifications of our 2 cameras. They share one thing, that they have 2 rotating lenses. Both cameras have 300mm lens. A3 Edge from each 1 kilometer can have 1.5 centimeter resolution, ground resolution. Nasiar has 5 centimeter ground resolution. Other parameters are more or less technical. That's what the package includes. Land-based systems. Originally, we provided a cluster land-based system, which was quite bulky, and now we can live without them, and we can work with server-based systems, all-in-one so-called system. It is much less expensive than cluster system, and it ensures good productivity, and also based on different number of cores. 60 core system is our basic approach, basic package. It includes land-based storage, about 48 terabytes. That's quite a commendable server system, which can ensure high productivity and reliability of all the projects. That's what the image looks like in A3 cameras. That's the whole image, which was all 2 lenses are rotating, and during the rotation they synchronously make photos. Each image is of central projection or straight image. They are then processed in Lightspeed software. As a result, you get this one image that many different suites and systems can work with, including PhotoMod. Some of them are compatible with triangulation. Others can build digital elevation model or regular stereo imagery. The vertical part of this image and oblique parts of this image are programmed during the flight planning. So you can fully manage it, it's fully manageable before you start putting together a project. If the overall view is 110 degrees and you're flying over an urban area and your project is limited to an angle of angle of buildings by 15%, for instance, you can have different angles here. This angle, orthophoto or effective angle, you can have 2 alpha angle depending on the needs of your project, and as a result you can have the expected angles of buildings for your orthophoto or any other project to that matter. There are 3 different schemes of imagery. This is a vertical imagery or image acquisition used for regular orthophoto, and this schematic is used for oblique imagery. For oblique imagery, we need to know our angle here, or angle of obliqueness, which help us in calculating the route. So this is more important, not the orthophoto angle. And the third type of imagery, or image acquisition, that is a special type of image acquisition, is one-sided orthophoto. If you want high level of overlapping with your images, or you need to fly along some kind of border, and there is another type of barrier that you cannot overcome, you can use this type of imagery, which has only one-sided oblique image acquisition. Additionally, we offer 3 modifications of how we mount the camera in an airplane. The standard modification, when we mount it along the line of the flight, and 2 additional ones when the camera is mounted at 45 and 130 degrees.
Let's say you need to make a flight for oblique acquisition. Typically, every point on the ground is to be covered from 4 sides by images. If you have only one camera, A3 Edge, you mount it along the flight line, along the fuselage axle, and you do the side overlaps. If you have 2 hatch airplanes and you can mount 2 cameras, 2 sensors, one of those sensors you can angle for 45 degrees, the other 130 degrees, and fly like that. This way you save flight time, and still you will be able to generate every point on the ground from 4 directions. These are different flight scenarios. If you need a DSM with facades for 3D modeling, you use this type of flight. If you need a DSM with true ortho, then you need a separate, a different flight scenario. Another thing to be taken into account during actual aerial survey is that your area will always be larger than your object's area, because you also need to cover the external sides of the object or the site with oblique images as well. So this needs to be taken into account, and our flight preparation application takes that into account. These are a few parameters in terms of data acquisition. For 5, 7.5, and 10 centimeter GSD, and an area of 100 by 100 meters. So we're talking here about the size of an average European town. So for a 1 camera oblique flight, you will need 2.5 hours to do 5 centimeter images. If you use 2 cameras, you will need less than 2 hours, or even less than 1 hour for 10 centimeters. If this is a regular flight without cross overlaps, you need to generate true photo. For that, you will need slightly over 1 hour, and in the 10 centimeter resolution, less than 1 hour. This is a case study from St. Petersburg, Isaac Cathedral. It was St. Isaac's Cathedral. It was used for oblique image generation. This is an example of the same project. This is taken from the conferences area, 80 centimeter GSD. The project was made this year. 3.5 kilometer height of flight. This is an interesting project because the height was 12.5 meters, GSD 30 centimeters. They used the Learjet aircraft. The flight took 7 minutes for 3 surveys, for 3 strips. So they flew in the night, and in the morning they could collect images. And the territory was quite large. Using the same project, a DSM-based true orthophoto was created from point cloud. Here the area size was 140 square kilometers, DSM density 100 pixel per square meter. To process a regular computer was used, not even a powerful system, with 1 GPU card. The processing time 81 hours. But if we want to convert to 15 meters, then you need to add another 29 hours. So this is a resultant through true orthophoto. There was no parallelization used. We're now working on parallelization of these processes to use them on cluster systems or in service. This is another example of Valparaiso with a dense DSM. This is a cloud. This is a point cloud. And this is orthophoto generated from that point cloud. Another example with point cloud involved. And this is the orthophoto. In fact, national mapping agencies are very skeptical about this product. Still, last week we received good news from Germany, where the German National Agency is willing to accept DSM-based orthophoto as a photogrammetric product. Today, we and other companies work on enhancing and improving the quality of this product, because sometimes pixels are missing, you can get wrong colors, black colors need to be interpolated. So there is a current effort in several European companies to fill that gap, and I think that in the several years to come, this should be a product that will replace ordinary orthophoto, because it has a bunch of advantages. When you get an orthophoto, you can fly in many cases at a much greater 2 alpha angle. So you can expand the length between lines of flight, opening up whole new opportunities. This is oblique vision, software that allows you to import various layers, and then you can do measurements on individual images. Acute3D, I talked about it. We did many cities like St. Petersburg, Tianjin in China. We did it completely using our camera and Acute3D. And a lot of smaller objects of the same kind. La Palisse is a town of 2,500 people. Well, I guess that's it for me. Thank you very much for your attention. Your questions, please. So you started nicely saying why you need all of that, and it all ended in orthophoto. Why would this be needed? I mean, oblique images for customers. I think that's what I said in the very beginning. I think you said the question, but you didn't answer it. Well, looky here. It's interesting to monitor a site from different sides, right? Do you have any case studies, any examples? Yes, there are. I don't have them here. I have them on my computer. I don't have them here. Oblivision, for example, has a central primary website where you can see who uses these oblique imageries and for what purpose. So there are no standards in this field. No standards yet. I don't even expect any standards in this field. I think this is used. There are a lot of potential customers who can use it, and I don't expect or predict any standards to come. Finally, there may be some accuracy demands. For example, if you need to do a municipality and to view streets and buildings, or to take stock of your residential estate, then you don't need accuracy. You just need to know if you have anything. But once you start measuring things, then you certainly need a certain level of accuracy, and this is where differences might come in. Any other questions? Yuri, I thank you very much, because I myself will make a presentation on dense DEMs later, so I will certainly contribute to what you said and repeat many things. But we didn't make a deal on it, right? No, we didn't. I have both a question and a comment. I agree with the moderator. Why do we need it in the first place? Because it seems we have two types of 3D models, vector model and point cloud. Vector models are more understandable for me, but when you create dense DSMs, it gives you nice pictures, but there are no mapping properties. So out of this points cloud, we can't say if it's a house or a tree or whatnot. And we are forced to do further operations, and those other operations involve other technology which are much slower than creating a dense DSM. So what I wanted to say is preview a roundtable the day after tomorrow. You know, I've participated in several discussions around the world, and the answers I got were a lot similar to what you just to how you just responded. These applications are kind of artificial, you know. There's a stretch here. There are very few orders, very few tasks involving oblique imagery. I know of a project in St. Petersburg. You know, Meridian is doing not well at all financially. I mean, it's a good project, but there is nobody to buy it. And this is where I think we need to find rationale for having dense models, because we know how to create them, but the area of application is still under question. I agree with you. I could not agree more. I mean, we are in the very beginning of this process. We don't know how it should be used. I agree, yeah. I think that shortly this will be resolved. For example, ArcGIS does it already. And you can build a full-fledged GIS using triangulation. It's a triangulated texture model with all the attributes. What do you link your attributes to? Where do you link attributes to? To polygons, to triangles. Why? I don't see any sense in it. So there is a bunch of triangles spread out, but you need to somehow distinguish, delineate a house. In most countries, there is a mapping basis of cities. So it's a pre-created project. Once you know it, it becomes elementary. I agree. We need vectorization.
I think we are already in the middle of this panel discussion that is supposed to take place. I think what is very convincing, what you showed here, is the image that was created with oblique vision. Yes. Because everybody talks we need city models. I think city models for viewing, they will not find customers. They will find it one time. But who is updating? So if you go ahead and the models are there with city GML, obviously, like you said in the paper from Russia, it's a tremendous extra amount if you object model the landscape. But you can do it for certain parts, maybe just buildings. And then you attach all the attributes. It requires completely new designs. ArcGIS you cannot use for that. You need some other tools that need to be built up. But from many companies right now, that it's a chance for Russian scientists, essentially, to do that sort of thing. And like you said, maybe restrictive policies have some advantages because you can do it better. It all depends on price. And as far as if it can be done cheaply, maybe one of these days it can be done more cheaply. But the way is clear, I would say. Oblique vision example is a good one. Thank you.
Thank you.
Давайте поблагодарим.
Let's thank Yuri and continue this discussion at our round tables.